All right, let's look at another rational function. This time it's given to us in both standard and factored form, which is quite nice. So when we're asked to simplify, it's already factored, and we just need to figure out what's showing up in both top and bottom for a factor. If we look at it, we have 3x squared times x plus 2 all over 3x minus 7 times x plus 2. The x plus 2 shows up in top and bottom, so we can get rid of it. And we wind up with 3x squared all over 3x minus 7. Keep in mind that we cannot simplify those 3's or the x's because the 3x squared up top is single, but that 3x in the bottom is married or in a relationship with the negative 7 or with the 7 because it's 3x minus 7. They have a bond and you cannot break that. So it cannot simplify further. Remember, with your domain, you're going to take your unsimplified denominator and set it equal to 0. A lot of people actually find the domain before they simplify anything down because then they'll make sure that they don't miss any of their restricted values. So if we're taking each of these factors and set them equal to 0, we find out that x is equal to 7/3 and x is equal to -2. These are our restricted values, the numbers that we cannot use because they would make our denominator equal to 0. So when we're doing our domain and interval notation, if you need a visual, remember you can always do the number line, negative infinity on the left, positive infinity on the right. -2 is negative, so it's going to go closer to negative infinity. 7/3 is positive, so I'll put that close to the positive infinity. Remember, it does need to go in order, even in your sketch. Negatives to the positives, working our way bigger from left to right. And then when we write our domain, we're going to have 3 pieces to the domain. We're going to have negative infinity to -2, which is our first set. We have a jump over a restricted value, which means we need a jump rope the union symbol. -2 to 7/3. And then we need another jump. And our last interval is 7/3 to infinity. And I wrote too big. This should all be in one line. But as long as you have all the parts and their union together, you'll be just fine. Our vertical asymptotes are what's left in our simplified denominator. So we're going to take 3x minus 7 equal to 0. And we find out that we have a vertical asymptote, a VA, of x equal to 7/3. So our vertical asymptote, that dashed vertical line, is going to be 7/3. Remember, all of our restricted values either wind up being vertical asymptotes or holes. Okay, so if you have 2 restricted values, you're going to have either 2 vertical asymptotes, 2 holes, or a combination of the 2. We only had 1 vertical asymptote, which means that our other restricted value is going to be the hole. Remember, whatever we canceled, it was the x plus 2. So x plus 2 equal to 0. Cancel culture. If you cancel people when they're an a-hole. So if you cancel something out, you have a hole. Our x value is x equal to -2, but we want the coordinates of the whole, which means that we need to plug in x equal to -2 into the function. And you need to use the simplified version. So plugging in, we're going to have 3 times -2 squared all over 3 times -2 minus 7. You can do this all in one for your calculator if you want. Otherwise, you're going to have 3 times +4, which gets us 12 up top, all over -6 minus 7, which gets us -13. We don't like negatives in the denominator, so either move it out front or up top to get -12 over 13. In our ordered pair, we had -2 for x and -12 over 13 for our y value. And remember, this is a hole in our graph, so it literally looks like someone just took a hole punch to our graph. Okay, next we're asked to find the y-intercept of h of x as an ordered pair. So for a y-intercept, remember that we need to plug in x equal to 0. We're going to plug that into our simplified function. We're going to have 3, instead of x squared, we're going to have times 0 squared all over 3 times 0 minus 7, which gets us 0 up top all over -7, which is still 0. So our y-intercept is the ordered pair 0, 0. But notice that both x and y are 0, which means it's going to show up again when we find the x-intercept. Remember, you can have multiple x-intercepts. Actually, the last function that we reviewed had 2 separate x-intercepts, but we're going to take our simplified version, so 3x squared, 3x minus 7 in the denominator, and we're going to set that equal to 0. But remember, whenever we have just a fraction equal to 0, we don't really care about the denominator, because we could multiply both sides by 3x minus 7 and make it go away. We really only care about the numerator when we're finding the x-intercept of our rational function. Divide both sides by 3, we get x squared is equal to 0. We could do the square root property here, remembering your plus and minus on the right hand side. But we have x is equal to plus or minus 0, but you know that we don't really do positive or negative 0, we just have 0. And notice that we get 0 for x after we plug 0 in for y, and we're right back to the same intercept that we found in part E, but we made sure that we weren't missing a second intercept.